We shall get started. Okay, so as I might have told you yesterday, so today we are going to start a new topic called statistical inference or inferential statistics. Okay, so just can you tell me what does inference means? What does inference means, or what does it stands for? Anyone? Try. Let's see. Conclusion. Okay, good. Anyone else? What do you think what inference means? Inference is like kind of the truth or the supposition that you may that you get out from a problem, right? So basically the idea is statistical inference is nothing but the process of making guess or inference about the truth from a sample. Okay, remember we are talking about a sample. Why we are using a word called guess. Okay, if you were using a population, you do not need to write this word called guess. There is no requirement because then you exactly know what it is. Okay. Okay, let's start with the basics. Okay. In statistics, and I was very surprised to learn when I learned myself that there is something called, or in probability theory, there is something called central limit theorem, which basically establishes that in some situations when independent random variables are added, their properly normalized curve tends towards a normal distribution. Informally, people like to call it a bell curve, even if the original variables themselves are not normally distributed. Fundamentally, what they are saying is you can start with different kind of probability distributions or different kind of initial distribution. Okay, but you keep averaging them out. In long run, they start to look like a bell curve. Means of course you can perform it on a continuous system or a discrete system. It kind of does. So let's take an example programmatically and let's see is it true or not. Okay. So does any kind of distribution, initial distribution when averaged out starts to look like a bell curve or not? Okay. So let's just see programmatically, does it follow CLT or not? Okay. Okay. So I've written like a very small code to kind of make it work. So we are gonna use NumPy, okay, Matplotlib, and there is an animation package which will be very useful here. Okay. Now we are gonna do simulation. So let's start with very small simulation first. Okay. N is equal to 5, and okay, fundamentally the simulation is like this, guys. Okay. There's a dice roll. Okay. So how many sides does the dice has? How many sides does the dice has?
6.
My point is, I will take in increasing order. I will kind of roll the dice again and again and again. So dice is kind of rolled again and again and again. Okay, where there are different faces and whatever it is. And whatever comes out, whatever comes on top, let's say, I keep adding them in a list. Okay, So let's say right now one came, in next experimentation maybe 5 comes at top, and so on. And we will take an average of them. So whatever, we will divide by the length of the array. And then we will plot them again so that basically it normalizes. Okay. So what we are doing is we are taking a list, if you can see here. Now for I in range 2 to n, so at least minimum, because we are taking average, so we will be using at the start a minimum two dice. Okay. And we will keep increasing the number of dice. Okay. Then we are using np.random randint from 1 to 7. Of course 7 is excluded for I in this range of 2 to n, so including 2 excluding n. And whatever happens, we are going to take average of 8, and we are just going to keep appending to a list called average. Okay. And just to check it out that has it been printed or not, we can take it, or we can kind of print them out, although this might throw an error right now, so I will change the number here. So you can see what has been printed or what has not been printed as of now. Okay, so this is gonna throw error, so maybe this is good one. And I have to find a function called CLT, okay, which will just plot something. Okay, so maybe let's restrict it to a smaller number. Okay, so it will just plot things, and it will annotate all of this stuff. Okay, and this animation function is just gonna show you in intervals of 4 or 5, but don't worry, let me show you how it looks like. Now the problem is this code doesn't run on Google Colab correctly. Okay, the animation part is just doesn't occur. So what I have to do is I have to run it on my own environment. So let's just do this here. CD CLT. Weird. Where it is going? 1 sec. Let me just look at it. My path is data. Sorry. CD data. Okay. So now I have to execute it. So let's use Python, and let's execute the code. CLT demo. And you can see there are, let's say, 3 outputs. Basically it is just trying to take average, and you can see it looks like, say, it looks like single roll, and you can say that, okay, basically in all cases there are different averages, and this looks like a uniform distribution, and that's correct. Okay, so let's change the values now. So let's increase this number n, so maybe let's increase it to 10. Okay, so this we can print it out till maybe 5 this time only if you want. It is 10. Save it and then rerun it. And now you start to see, again, it's not a proof of anything. You can still see it is highly scattered. So the initial distribution might not look like anything. Okay, and that's to be expected. This is how things work in the initial days. Okay, and let's increase the number a bit. So maybe let's use 50 this time. Okay, and 50 here as well. Let's run it again. Now you might start to see some centralizing happen. Okay, some centralization of data to start to happen. So some points, or most of the points, are around the mean itself. Okay, and just to prove it a bit better, let's go all the way so that you can see this. And again, let's do it for a large number, slightly bigger number, 100. Maybe let's even print out total of 25 and 100. Let's do this. And you can start to see, even in initial it might have looked different. Now you will start to see there is a much more better centralization. And let's really increase the value this time. Let's go for 500. It's a good idea if we can change this one as well. And let's run it. And remember, the experiment is totally random. I have no control. I am not choosing any number here. So this is a random die roll which I am trying to do, and the experiment results are in front of you. And you will start to see as we go along that it will stop at 500. Yeah. Now you can see there is a high centralization, and you can see it might started to look like a Gaussian curve already. Okay, of course I have taken discrete. I can also take continuous ones, so that can help me out in this one. But you might get the idea that what has started to happen. And if someone wants to be even go one step further, maybe you can take a bigger step. And again, it will take some time, but you will start to see this, that again it kind of centralizes even when we take like random kind of random die roll, but it is going to happen. And this is the one of the basis like why we like use normal functions so much in statistics, probability, machine learning, because we can just take average of data, and after a while it starts to represent, or it starts to kind of become like normal distribution. You guys can also replicate this code or write this code on its own. uh, I have also posted this code in your folder already. Okay. Okay. So you might be able to see it has literally centralized and basically most of the points, and it might start to look like a kind of a Gaussian curve or a bell curve. Okay. Okay. Of course, with a very low variance as well. So this is the basis of CLT, that why we use CLT, or why the assumption of CLT is true. But remember, when you do it like long for a long time, not just for one data set or something, or just not for one column, if you perform this procedure many times, central limit theorem says that the distribution of average will be closely approximated by a normal distribution. And this is why any kind of, you can take a coin flip, you can take a die roll, or you can maybe even replicate this with cards. Okay. You will realize that basically this becomes true. The curve or the plot that you will get will start to look more and more like normal distribution. Okay. So is this clear? And maybe you now might have understood why this assumption is taken.
Sorry, can you please repeat? Yeah, I just joined. So.
Okay, so we were just discussing about central limit theorem, and we were just establishing that if you do any of these experiments, let's say when any independent random variables are added and their properly normalized or average curve is taken. Now the repetition needs to be in a higher number, let's say 50, 100, 200. Then the normalized sum or the curve starts to become like, if you just take a smaller one, it will look like flat or something. But as you start to repeat it a lot, you will start to see it will start to become much more like a normal distribution.
Okay.
Okay. And this is the assumption of CLT that is called as central limit theorem. Now there is a useful interpretation that I want you to note it down that, okay, now there are different notations. So some people might use small s. So in some books it is used as small s. So the small s is standard dev of sample x. One sec. Or some people just use it like this, same thing. But whenever this is used, it is always mostly looking to standard dev of population. N is usually the sample size. And capital N is size of the population. So I want you to note down this formula because this will be incredibly useful after a while. Okay.
Where you have pasted the code?
Sorry, what?
A code, the code which we have run. You said that you have pasted in folder.
Can you see the statistics folder in your drive?
I was trying to because I only see Python.
No. For statistics, there is a different folder. I hope you know this, right?
I'm in middle, like my laptop got crashed, so I wasn't able to join few classes.
Yeah, no. This discussion happened on WhatsApp, so please check it out. Okay, the correct link.
Okay.
Okay, all right. Okay, so now we are gonna go towards the statistical inference idea. So we established the basics of CLT. Now what we are saying is, now in interval estimation, so interval, what is the interval? Let's first define the interval. What is an interval, guys? Anyone?
The distance between 2 points.
Distance between 2 points, okay.
Differentiation with within two samples.
Differentiation, maybe not the use of correct word. Anyone else? Interval, as she rightly said, was it's kind of a distance or a gap. The better word would be like a gap between these 2 points or upper or lower limits. So let's call it upper limit, and this is the lower one. So the distance between them is referred as interval. Okay. And of course, interval can be in form of a space, it can be form of time. So now the question is, and let me use the question properly. So let's take this example of Coca-Cola. So we get this bottle of 750 ml. Okay. Now, one day I get a bottle, I open it up, and then I get a bit creative, and then basically I try to like measure it properly. And I get like 739 ml only. So can I sue Coca-Cola about giving me less quantity?
No.
Okay, yeah, we'll come on, don't worry. So because it advertises 750 ml, we are estimating that because it's a process, the mu, mu of the population or the sample is 750 ml, okay? Because that's what they have written, right? So there are cases where you might not know the population mean or sample mean, that's a different case. So you might have a case of mu known that you know the mu, okay, mu of population. might also have a of a sample that this is known, but the population statistics is not known. Okay. So first of all, of course, there is a problem. Do you know the mu or not? So we are operating under assumption that we mu of population is known. Okay. It is given by the problem statement or then the product description. We already know this. Okay. Now the problem is population standard deviation. There could be a sigma known case or sigma unknown case as well. Okay, so we will try to cover both of them, and I will try to explain you why both of the cases are important in making an estimation. Now the problem is, and basically why interval estimate is important, because there is a margin of error. Do you understand this phrase, margin of error?
Acceptable error, maybe?
Acceptable error. Okay, good. So the idea is a point estimator cannot be or cannot be expected to provide the exact value of population parameter. So if your bike has a mileage of 47 kilometer per liter of petrol, you cannot always say like whenever you will take a bike or whenever you will fuel up 1 liter of petrol, it is gonna actually give you exactly 47 kilometers, right? What does it 47 kilometers per liter means? Or what does it signify?
Expected, yeah?
It's expected or it's the average, but again it's average, right? So there would be some variance, right? So maybe mentioning it like this would be more better. 47 plus minus 5 kilometer per liter. So that will be called, or that would be like point estimate plus minus margin of error. So this 5 kilometer is a margin of error. Okay. Now let's take the example again, just to understand everything properly. So cause I got 739 ml and I'm very angry about this. I go to Coca-Cola website and I study or I read that basically Coca-Cola in its fine prints is claiming that the bottle would be 750 ml plus minus 10 ml. Okay. Now I got 739 ml. So can I sue them?
Yeah.
How? How would you prove mathematically? That's the question. Remember this part. Now remember, I have just opened one bottle. Where is this noise coming from? So first, okay, so try to imagine like there, let's say Coca-Cola filling process. So what happens is 750 ml is here, okay? Now most bottles, let's say this is the priority. So most bottles will be filled around 750 ml, okay? So it's very hard to measure exactly, but the machine will let's say take care of dropping 750 ml exactly, but let's say there is some variation. Okay, I've tried to like draw a Gaussian. So the idea is most of the bottles would have around 750 ml plus minus some. Okay. So let's say Coca-Cola is claiming 750 ml plus minus 10 ml. Okay. Now the problem is if I take this process to be Gaussian, you need to know this 10 ml is it like one standard deviation, two standard deviation, three standard deviation, and this will come in handy after a while. Because the assumption is that the process or it follows like a normal curve. So in normal curve, we have a habit of writing mu plus minus sigma with some kind of a z value, or some z is nothing but it's just a real value. Okay. Okay. So till what
C is a
standard?
real number.
Sorry.
You meant to say Z is a real number, or?
Yeah, it's a real number. Okay.
Okay.
It can take values from negative infinity till positive infinity. Okay. Now, why my point was, okay, so this is gonna follow a normal curve. Now, basically, I just want to understand, and now there is another problem. So when you are claiming this statistics, do you mean all 100% bottles would have this range itself? Now, because we know Gaussian goes from negative infinity till positive infinity, we know you can never exactly get 100%. Okay. Basically, you can't account for all the cases. That's what I'm trying to say. So, okay, let me remind you a few things. So in a Gaussian, when you have a mu plus minus sigma, how much population percentage it contains? This should be 68.4 almost. What about this?
95.
95. What about plus minus 3 sigma?
99.
Okay. So basically, I need to know that plus minus 10 ml that you are looking at, how much sigma it is, because I want to have something called confidence. Okay. So if this 10 ml is just for standard deviation, then we have 68.4 confidence only. Why? If 10 ml is basically one standard deviation, then I'm saying we just have confidence on 68.4% as only. Why?
The sample size is less.
Not exactly. No, they are mentioning 10 ml as, let's say, for standard deviation only. So doesn't it means that out of all the bottles manufactured by Coca-Cola, because it's a normal curve, okay? So because normal curve follows this property that mu plus minus sigma will only be 68.4%, right? So what it also means is if you are claiming 750 ml plus minus 10 ml and you are telling me that sigma happens to be 10 itself 10 ml, then overall is, so only 68.4% of total bottles will basically follow this rule, right?
Yeah,
Okay. What if the 10 ml was basically 2 standard deviation then?
95% of the bottles will get
Exactly. And 3 standard deviation then?
99%.
Very good. So now look how people will fool you. And this is the point of quality basically. Let's say there is a precision tool, okay, which needs to be made exactly 500 millimeter, so half a meter. But this precision tool has a small, let's say 2 mm, okay, or maybe even less, let's say 2 mm range of interval. But the company is very specific with the marketing and everything or whatever, and it claims 99.7% CI, confidence interval we like to call it. Okay. Now another company comes and they sell the tools for cheap. Now the process or anything has not really changed. They are also claiming the same thing. But in very fine prints only you realize that basically they are only claiming 64%, 68.4% CI. But they are selling their products for 20% less. let's say compared to this price, whatever the price here is. Can you see the trick? What is happening here?
Yes.
Now, most people will just look at this data and they will be happy. Problem with normal distribution is, of course, some examples are gonna spill over beyond this range as well, but how many examples are gonna spill over? So this one basically says that because 2mm is 3 sigma, so you can understand sigma happens to be 2 by 3 mm, which is actually very good. It means the tool is much more precise. Here it is just claiming 500, so 2 mm is 1 sigma. So basically sigma means 2 mm. So you can see the tool will be more imprecise in this factor, in this manner first of all, and more of the tools or less amount of tools would be even falling under this range compared to this one. So this company maintains a higher standard compared to this one. But cause general people do not understand about CI or confidence interval, they are easily taken for a ride. They just check these values and they think 100% of the examples or samples would be exactly in this range. And this is the truth. No, they are not. Did you get this idea? What I'm trying to flout here?
Yes.
Okay. Anyone has any doubt, you can ask me.
So I need a little more clarity on this one. So going to the previous example that you had, sigma.
Yeah, the
Show this
Coca-Cola
one.
one.
Right. So in that example, so 739 basically is falling within that 1 sigma range, or is it a spillover? They are spilling over like that 1 sigma, right? Or
Yeah, but depends, no? We will have to, let's say, ask the company, okay, when you say this range, what is the confidence interval? If they answer 99.7% because they want to be precise,
it's 3 sigma.
then
Okay.
yeah, then the sigma is
3.3.
very good, basically 10 by 3. Okay, so Miss, look, there is another topic called hypothesis testing, and I will explain you all of this. We are gonna go in that direction anyways. But just trying to explain you that just because they have mentioned 750 ml plus minus 10 ml, it is not a complete information. You need something else, and that is called a confidence level or confidence interval to know that how many samples or how many of total population falls under this actual range. Okay, because the idea of Gaussian distribution is it can go from negative infinity or very close. So basically a bottle might not be filled at all, but that would be a very rare case. Means those kind of bottles are separated out. Sometimes it happens the machine doesn't work and a bottle is passed ahead without filling, but then there is a fan or something which basically pushes that empty bottle out. And sometimes of course it can fill up so much that it can come out of the bottle itself, and those kind of bottles are also discarded. So of course they maintain a very high quality. I'm not saying that it is not, but my point is anything, any natural process or any machine does have it. It will not get you exactly 750 ml. Time and again something will change. Now depends how good the company maintains its own standards. You can be sure that even if there is a variation, there will be very small amount of variation in their production. That is what you expect from a very good
Sure.
company, right? You
Sure.
expect quality.
Right. So that much I understand the CI and the precision level rated. But the bell curve, for example, you drew the bell curve and you showed like 750 and then the 739 kind of falling out of the range. In when you say 739 and 750 plus minus 10 ml, so within that bell curve, is it like specifying that it is falling like out of the boundary, like towards the left
Yeah.
side?
Yeah, so I'm getting where you are gonna get. It is basically
Oh,
called
okay.
hypothesis testing. Don't worry,
Okay.
we'll
Okay.
definitely go there. Okay, so very first problem is you just took like one sample, right? So first, in this error estimation, we need to have an optimal sample size. So we will talk about that, because without knowing optimal sample size, you cannot go and say, because they can just say, okay, it is a bell curve. So of course there is something which can fall out of this acceptable range as well. So first you need to know how many samples minimum you need to take to solve the problem, right? So that is the part that is first we need to study, then only we can go for that discussion. Okay. Now, in order to develop an interval estimate for the population mean, the margin of error must be computed using either the population standard deviation or the sample standard deviation small s. Okay. Now, sigma is rarely known exactly, but often a good estimate can be obtained based on historical data or some other information. We refer to such cases as sigma known case. Okay. So let's start with sigma known case and let's check what is a z distribution. So there's a picture that I want you to see. And if you want to take a screenshot or something, it would be nice because we will be referring this picture a lot. Okay. So let's start with z distribution. So in statistics, z distribution, okay, fundamentally z distribution is normalized Gaussian curve. Okay, it is the Gaussian curve itself. Okay, in statistics, z distribution is used to help probability the percentile for regular normal distribution. It basically serves as a standard where normal distributions are measured. Z distribution is a normal distribution with mean 0 and standard f1. So in a z distribution is again just a normal distribution. So you have a function like this, where mu is 0 and standard f or variance happens to be 1. How would the function would look like in the equation wise? If anyone remembers the equation for normal distribution. So z curve will look like, now remember in z, mu is 0 and standard f is 1. All right. So can someone tell me the formula?
Into root 2 pi. It's 1 by
Sorry, what did you just say?
1 by sigma into root of
Okay, so
2
sigma
pi.
is 1. Sigma is 1, so you can
1
ignore
by
that.
Yep,
1 by root 2
to e power minus 1 half.
E to power.
Minus 1 half.
Good.
Into x minus mu by sigma, again the 1.
Again mu is 0.
Yeah. This is the x square.
Because sigma is 1 and mu is 0, so that doesn't affect anything here. So this is the equation for normal curve. Okay, oh sorry, z distribution. So the idea is very simple. Z distribution is a normal distribution where mu is always 0 and standard f is 1. This is 1, this is minus 1. Okay. This is like your standardized normal curve. Is it clear? Okay. Remember what was IQR?
Interquartile range.
Very good. What is that exactly? IQR range in terms of value?
Middle 50.
Q3 minus Q2, Q1.
Okay, there is like a lot of noise. Can you guys just type it out if possible? Whatever you wanted to say. Okay, don't worry. So the idea is because it's a normal curve, if I go from minus sigma to complete positive sigma, we know it is 68.27% of the overall population, right? What about if I wanted to understand IQR? So IQR is nothing, basically it is quartile 3 minus quartile 1. So now the problem is, how do you know where this is? Now, of course, this is a normal curve, so we kind of can get the values, but the idea is how do you get these values? So Q3 it will be basically at 0.6745 sigma, and similarly Q1 will be at negative 0.6745 sigma. Now you might be thinking, how did I get these two values? This is called a Z value, okay? And I told you now it's a real value. So basically, whenever you write your interval estimate, it should be in this form. Now, of course, this sigma is population sigma, not the sample one. Now the problem is, how do you know Z value, or how you come to know the Z value? Now there are charts, there are online calculators to do this. I will try to explain you through charts, and of course you can find some online mobile app or online websites which can do this for you as well. Okay. So my point is, interval estimate has to be mentioned in terms of Z. Now, so basically the idea is, here is mu, and let's say the acceptable range is, or acceptable interval is this one. So this one and beyond this, so okay, so beyond this is mentioned as alpha by 2 and alpha by 2. The idea is this is symmetrical or well balanced. So there is acceptable range of this one. Okay, sorry, actually not a good figure. So there is acceptable range, and you need to know these 2 points. That what are these 2 points? Okay, so basically you want to write it like x mean, so the average plus minus some Z value determined by alpha or alpha by 2, and alpha by 2 will be in when both sides are available, or when you have to calculate on both sides. That is called a two-tail problem. Okay, so alpha by 2, let's say in this case, into standard deviation of the population. This is called interval mean, or interval estimate of the population mean. Now you might be starting to wonder, like, how did I am getting all this calculation? So first, let me give you a simple idea. First, I want you to note down the value of Z, how to calculate the value of Z. So Z value is nothing but you take x minus mu and divide by the population standard deviation. That will give you the Z value. Basically, it is kind of a ratio for standard dev. Okay. So now there is another equation that is again very similar, but you have to remember this. Okay, that so now what is the error value? Error value can be taken as Z alpha by 2 into population standard deviation, which is nothing but Z alpha by 2 into, sorry, this is sample standard deviation, population standard deviation by root of I. Okay. So 1 minus alpha is the confidence coefficient z alpha by 2 is the z value providing the, so it is written as a, but it is alpha, okay guys, in the upper tail of the standard normal probability distribution. Okay, first let me explain all these tails and whatnot, because otherwise it becomes very confusing after a while. So let's draw a normal distribution once again. But if I don't know. Okay, let's use this one only. Let's use a proper normal distribution first. So assume this is a normal distribution, okay? And you have your axis, of course. So here is your mean, mu, okay? Now, and this is the problem statement that you have to understand. Basically, arbitrarily, I got a point here. This is called x, okay? And so, okay, so now if you are taking only one part out, let's say if this is the part out which has been left out, so you are only worried about, let's say, not being greater than some value or some threshold, and rest all is okay, negatives, all the lower sides and everything is okay. So they basically, okay, so if I integrate the whole z curve, z distribution, what I would get if I integrate it from, what I would get. You integrate a normal distribution from negative infinity till positive infinity, what do you get?
1.
Very good. So the whole thing will be mentioned as 1. The whole length, what it means is that if you go from negative infinity till positive infinity, you get 1 or basically 100% of the population. Agree? Okay. But this area is called alpha area. Remember this, alpha is not the length, it is the area. So my point is, or the question will ask you someday like this, that if this is the limit x min whatever, so can you explain in terms of or some kind of coefficient of sigma standard F, that how much of the area or how much of the population is being left out, so that you know what would be a percentage error or something. Okay.
Isn't this an assignment question also? I'm just wondering. Seems like related.
Yeah, it will be. Yeah, and
The,
either in
in the assignment you already had given,
yeah,
so there
the
was
question
okay.
number 5th will be there, but also in future there would be another assignment which will
Okay.
contain a lot of these questions itself. Okay. So remember, alpha is again an area. Okay, it's not the length. Even we write it like this, please try to understand. It's an area, that area or proportion of area that we are talking about. Okay, and the whole area is, let's say, considered as 1 if you integrate from negative infinity to positive infinity for a normal distribution or z distribution, which is again a normal distribution. Okay, so the point is, can you know what would be z here, z alpha? So these kind of problem where there is only one tail, so the idea is lower tail or whatever the upper tail is covered, these problems are called single tail problem. Single tail problem. If you have plus minus ranges, you cannot go beyond some number and you also cannot go lesser than some number. So let's say you have like this and this. So you have both of areas. This area is also not possible to go, and this area. So both of the areas will be considered because it is symmetrical, alpha by 2, alpha by 2. So again, the overall this one will be 1 minus alpha. Now there are multiple ways to calculate the z itself. Okay, so very first way that you just saw is, you might be given the x. So dividing x, so basically you need to know how far away from the mean you are, and x minus mu and divide by the in terms of standard deviation. That will give you z. Okay. But maybe someone doesn't gives you that. Someone says alpha value is 0.1. Okay. Let's say it's a single tail problem. Alpha value is 0.1. It's a single tail problem. So then they might ask you, okay, if it's a single tail, what is the z value? Okay, so you might get confused. You might not be able to understand how to solve it. Okay, don't worry. We will go step by step to help you out. Is this picture clear, or should I? Okay, actually, you know what? I will zoom it out a bit. Can you explain me what this picture has all this information about? Now there are some interesting accesses. The standard deviation should not give you any trouble, I guess. Standard deviation from the mean is clear.
Yes.
Okay. Now some people might be worried about this cumulative, and this is the worry. Okay. Cumulative is the area from negative infinity till, let's say, 3 sigma. Okay. So from negative infinity, the area calculation starts from negative infinity. Okay. So till here, see this value 0.1%. What it means is from negative infinity to, let's say, I do integration till negative 3 sigma for a normal distribution. You will get a very small value. Okay. It's 0.1, right? Similarly, if you try to go from,
Is it the area from sigma to infinity minus infinity to 3 minus 3?
yes, this is why I have shaded this area. Okay.
Okay, from
See,
last. Okay.
yeah, from negative infinity. So area calculation will start from negative infinity itself in this for this chart. So now you understand what does this means? 2.3.
It's
2.3.
minus infinity to minus 2 sigma.
Very good. So I'm just trying to shade with different colors so that it is clear for everyone. So what it means is if you take a normal distribution and if you integrate it like this, you should be able to get, okay. Similarly, what is this 15.9? Same idea, just change the color. Gain some value starting from negative infinity to, if you just keep doing the summation. And of course, overlapping the previous one, it doesn't mean that we are excluding the previous ones. Okay. So from negative infinity to 1 sigma, negative 1 sigma number, okay, normal distribution, that will give you 0.159. Okay. And of course, if it is well-balanced graph from negative infinity till 0 or till mean, you will get the exact 50% of the curve. And similarly, you can keep going ahead. So now beyond 50, if you go till positive 1 sigma, then it is total of 84.1% of the population. If you go from negative infinity till 2 sigma, positive 2 sigma, or mu plus positive 2 sigma, it will be 97.7. And similarly, if you go from negative infinity till 3 sigma, it is 99.9%. And if you keep going beyond, so the idea is till infinity, you will get 100% of the. So basically from negative infinity to positive infinity, you are gonna get the 100%, but that is not achievable. So you are not gonna aim for. So your confidence interval in a normal curve can never be 100%. Okay, because then you are taking both infinities, and that is, we do not know infinity exactly. So what is z-score exactly? If you look carefully, z-score is nothing but the real value associated with the sigma. It's like a coefficient value. So you get the idea what z-score is? Z-score is now these are standard values. So now the problem is, what if you wanted to know the middle 50%? Let's say this is the middle 50% or IQR, interquartile range. How would you come to know this value? For this, you need a sigma value, right? You need some kind of z value, z into sigma. How do you know this exact z value?
Minus 1 sigma 2 plus sigma.
No, okay, because now you are wrong here, because
Okay.
think mu minus sigma 2 mu plus sigma is
60.
but I just want the middle 50%, that is IQR. So basically what we are aiming here is, what is this value of z sigma which just covers the middle 50% only. So let's say you have an alpha here. Okay, so what would be the alpha by 2 here? If you are covering the middle 50% only, then how much area you are leaving out on both sides?
1 minus alpha by 2.
So how much area is this? This is alpha by 2. Similarly, this is also alpha by 2, right? Because both sides you are leaving. So total alpha by 2. Okay, if you are covering middle 50% only, then alpha has to be 50% anyways, right?
Yeah.
Alpha by 2 would be
20.
So basically mu plus minus z 0.25. It is not written as percentage, it's just written as decimals, sigma. Now the whole problem is, how do you know z 0.25 is what? You cannot remember, and it's not expected for you to remember everything anyways. So now here we will require some help of Google. Okay, you need to Google, and please Google it on in your okay. You require a z table. Okay, let's see who has a better table. This green one is pretty good, I guess, according to me. So now what just happened? Just wanted to open the picture. Okay, I'm clicking the wrong thing. Open image in new tab. Yes, got it. So this is a pretty decent graph. Actually, let me remove all the writing. Okay, guys. Now, mostly the curve is available for one tail, but you can calculate two tail. It's not a very big deal. Okay. Let me explain how this works. So let me just reduce it a bit. Okay. So if you get a negative z-score, means you are this side, okay? So, okay guys, simple, remember, this value that you are gonna see internally is just an area, okay? from negative infinity till that z value. Okay, from negative infinity till that z value. Get the idea?
Yeah.
Nope.
Okay. So normally,
Can you repeat that? Sorry,
Yeah.
this any of these values is basically minus infinity to z value.
Yes, this value, let's say if you look at this, so you might ask like, what is this value, right? This is just an area value. So from starting from negative infinity till some z value, which will be negative, of course. So there are two charts, as you can see. So this chart can go from 0.0 something, although exactly 0 is very hard to get, to 50% only. Okay, if you want to see, I will show you. So the initial value is a very small value, as you can see, 0.003. But the maximum value you will be able to touch at any point will be 50%. See?
Right.
But you need to be taught how to look for this information. So maximum value is 0.5. And in the upper area, you will start at half, 0.5, and you can almost reach to 1. Again, because you have to go till infinity to reach 1. So you can see it is very close to 1. Okay.
The values on the left side, the first column on the z, these are the values in on the first row. What are these row and column values?
I will explain you. Don't
Oh,
worry, I
okay,
will explain
okay,
you all
okay,
of this. Don't worry.
okay. I thought you already
Now,
did that.
for doing
That's it.
this, you need to, although there is a confidence interval already given, you know what? Let's take a question. Otherwise, you won't understand what I'm talking about. So let's try to solve this question. So how would you solve it? So you want to open a new, let's say shop, okay, or new player, new basically showroom or something. So you want to know in different areas how much is the standard income, because again, if you are opening a physical shop, there is a high chance people living nearby you will be your most frequent customers. Okay. So you need to know basically the average income plus minus some standard deviation, or plus minus some difference. So how do you know this? How do you calculate? So you will require this equation. So interval estimate is, let me write it out. Interval estimate is nothing but mu plus minus error. And this is how you calculate the error. Now this is for two-tail. Otherwise, if it is a single tail, you should write z alpha to sigma by under root of n. Okay. So let me help you out and let me give you some z values by default. So for when you have, let's say alpha or alpha by 2, okay, let's start with alpha as 0.5, here alpha is 0.2. So remember, this percentage 80% CI confidence interval is CI is, our confidence is 1 minus alpha. Okay, Here alpha is 0.1. Here alpha is 0.05. Here alpha is 0.01. Okay. Now Z value is given for all of them, and I will also show you the similar thing in the chart as well.
Is the z-score also for single tail or two tail?
Yeah. Z value will change a bit, but you can use this Z value in calculation, current calculation. So I would really like you guys to note it down, because if I change the slide, you will miss this information. So please note down this information. These are some standard values. So calculate this. So find the confidence interval. So the answer I am looking is will be in the shape of mu plus minus error. So now you have to come up with two ones. So in one it will be 0.9 and it will be 0.95. So it's a two-tail problem. Okay, two-tail. So let's try to solve this. So how do you solve it? So basically mu is known, right? Mu is 41,100. But what you need to calculate is error. So error equation is Z. Now depending on the problem, it could be alpha by 2 or alpha to standard F by N. Now standard F is given. So you just need to put the values, and N is also given, right? So can someone tell me what is the error value itself?
So 0.002.
0.002. How did you
Oh, sorry. So error value. Sorry, to calculate 1.5. Sorry.
Sorry, how much?
1.5 or 0.9.
Okay, so let's say for 0.9, how much was the Z value that I already showed you?
0.0002. Sorry.
No, careful. Z value is 1.645.
Oh, okay.
So 1.645 into
750.
4,500.
Right. Divided by 6.
How much is this?
Under root of 36.
Sorry, how much?
You have the square root of 36, right? 6. So 750.
Sorry, you are right. Sorry, my bad. Yeah, equation was here. So total value is
750 into 1.645. So 750 into 1.645 is 1233.
Yeah, just make sure the math is correct. 1233.
0.75.
0.75. Okay, all right. So the interval estimate is In case of 90%, so first you take 41,000 plus minus 1233.75.
Yep.
What about 95%?
One 470.
Okay. In this case, you are saying it is 1470. So again, interval estimate will be 41,000. Sorry, 41,100 plus minus. You see, your range gets bigger when you want to be more confident. So if your boss says that, let's say about this range, so you say, sir, I'm 90% sure because only for 90% of the population, this might be true. If he wants to be 95% sure, you will use this estimate, 41,100 plus minus 1470. Because it includes more cases, simple idea of normal distribution, right? So if you increase the range, you will be covering more population.
I'm sorry, so there's some slight confusion. So it's just about calculation, but I just want to make sure. So this whole, so 0.95, the value that you showed in the table is 2.576 for the z-score.
Let me just go there. That is 1.96.
For the 95. Oh, I'm so sorry. So sorry. Okay, that's fine. Thank you.
You can also go on various websites and they have a z-score calculator over there. Although I will show you in both ways to calculate how can you get the values. Okay. Chart is available as well. So there's a better one. Okay, don't worry, we will get that as well. Okay, let's try to understand something first. In one tail problem, when I'm talking about alpha, just alpha. So alpha is this much, okay? Now you might be worried that we are getting z values directly in this chart. So how to read the value? Let's say, okay, so in z value only till second decimal place it is considered. So someone tells you z value can be you can get like, so someone tells you, okay, your z value is negative 2.43. How would you get this? How would you get the area now? So you will scan this. So first till 2.4 you will get here, and for next 0.3 you will go here and you will try to find the intersection. So in lower tail problem, if someone is coming with negative 2.43, what it means is from negative infinity to negative 2.43 sigma, you just cover, let's say 0.75% of overall population. Okay. because that is the borderline condition. You have to understand Z will be somewhere here in this case. Okay. Now maybe I can.
So the 0.75 is just an estimate, right?
Sorry.
So the 0.75% that you had, okay, from here.
Yeah, it's not
Okay.
estimate. It is actually
Okay.
value.
Okay. Sure.
So
Thank
it
you.
is not possible for us to like integrate every time, right? You can do the same thing. You can get the same result from integration as well, but it's very hard to integrate. Okay, it's not everyone is very good with it. So these tables are openly available over internet, and even in university exams, we were allowed to take help from Z tables and T tables to solve our problems because it's not possible to remember all of this. And similarly, if you have a one-tail problem where this area needs to be excluded, so let's say if someone tells you the alpha value, let's say whatever it is, 0.2 or something. So what is this Z value, right? This is what, or Z score as we like to call it. Okay, so again, fundamentally, you need to know the Z value already, okay, to calculate it like this, but reverse can also be done if you think very hard about it. If you tell me that this much area should be 80% of the overall area, okay, and this area exclusion or the outside region is 20%, so alpha here is 0.2 and you are looking for 0.8. How will you find the value in reverse? So basically I'm asking, how will you get the value as Z alpha or Z 0.2? How would you get this value?
One minus or?
Not. Now it is not a foolproof technique, but you will have to start from here and you have to go sequentially. Okay, so the idea is as you start to increase, so Z 0.0 is equal to, it is on the mean, so it is 50%. From negative infinity till mean is 50%. Z is equal to becomes 0.01. Slightly up more than mean, so it is like mu plus 0.01 standard F. That is 50 point. So if you look sequentially, it is increasing all the time. Okay, it goes like this, comes here, again increases, again comes here. So if you want to look for 80% from negative infinity till this point, what you need to do is you need to look sequentially. Now this is not a very good way, but this is the only way you can. So you come here, see? So what it means is somewhere here, somewhere like mu plus minus, let's just take 0.84 sigma. You almost get, although it is 79.95%, but let's just say it is very close. So now you know, if someone says what is Z 0.2, how do I know the value that it is 0.84?
Sorry, can you please repeat this part?
Okay, don't worry. Again, let's do it again. Okay, this area is alpha, this is a one-tail problem, okay? So this is the remaining area. This would be 0.8 if alpha is 0.2. So earlier, let's say Z value was given and you would calculate the area, okay? But what if reverse is true? I know the area, so I want to calculate Z 0.2. How would I calculate Z 0.2 in upper tail problem or a single tail problem? So basically Z 0.2
Isn't it right there?
0.2. So the rest of the area that I want to get is acceptable area, region of acceptance is also called, is 0.8. So you start to look like, if it is in positive, so you start to look like from, okay, so mean plus minus, mu plus minus 0.0 sigma will just give you 50% of the area anyways. Because till mean from negative infinity, you do cover 50% of the area. Am I right? Yes or no, guys? Come on.
Yes.
Okay. Now, as you start to increase this mu plus minus 0.01 sigma, how much is that area? Similarly, mu plus minus, let's say 0.11 sigma. How much is this area? 54.38%. So by manually looking, if I want 80% of the area, I can manually look in this chart. And again, that number will only repeat once, or you will just go very close, but you will not exactly get that number, which is the case here. Means it at one point, so there are only two numbers, let's say 0.84 sigma, you are getting 79.95% of the population, and then it is 0.85 sigma. Means we try not to go beyond the two decimals. It is 80.23%. So let's say we go with the lower one. So z 0.2 is 0. So this is in this line, right? And this intersects, this goes here. Did you get it? How did I solve this problem?
Yes, it's clear.
Okay. Now, what if I would have asked you the two-tail problem? So
one point. So basically, we cannot get exact 80%, but it is good enough for two
look,
places.
you can get it, but the charts are not available beyond the second
Correct.
decimal.
So this is acceptable. That's what I'm saying, right?
Yeah. Lower one. Just take the immediate lower one, not the immediate higher one. Okay.
Okay.
So the point is, it might be like 0.843 or 5 or something like this. But because we do not have third decimal information, we do not take that risk. But
right.
This is good enough. Okay. This is good enough answer. Now, what about two-tailed? So what about this middle one? Let's say you want middle 80%. Then how would you get it? Any idea?
First, we'll find out the minus part. Then once we got this plus part, then minus it and we'll get the middle one.
Very good. Simple idea is, if you know this is, okay, so let's say this is 90%. Let's say this is 90% of the area, and you can subtract it with the 10% of the area, this lower part. Wouldn't you get the middle 80%? So think like this, from negative infinity till some positive sigma, positive z value, you are getting 90% of the population. And similarly, from some value to some negative z, you are only getting 10% of the value. It will be balanced, so the z value will be exactly the same. So if you minus these two things, wouldn't you get from negative z to positive z, which will only contain the middle 80%? Because it is well balanced, so whatever z value will be here, it would be just minus z in this side. So how to find that? Again, there are standard tables, but if you had to do it from this table itself, then
So earlier we got the value of 80% is
0.84.
0.84 and minus it with this negative.
No. Be very careful. Be very careful here. That 80% was from negative infinity till this point. Now I want the middle 80%, not the from negative infinity. Okay, middle 80%. So it's a simple trick. If you think about it, divide it in alpha by 2 rather than doing alpha, do alpha by 2. So now you just need to find z alpha by 2, right? So rather than trying to find z.2, why don't I just try to focus on z.1? So 0.1, okay, fine. So how do I get z.1? That means z, how do I get z 90%? Simple, same, I will do the same thing. I will just look in this data. Where first 90 will appear? Here. So I can say it is, let's say 1.28, because it is symmetrical in both sides. So I can say mu plus minus 1.28 sigma will give you the middle 80%. So z alpha by 2, okay, when you have two tail, you will get alpha by 2. So if z 0.2 by 2.1 would be just 1.28. You can go in depth as well, but I'm just giving you this idea that how do I get this value. You have any questions, please ask right now, because this is a very important concept to understand.
Amritesh, here, if you go to bell curves are symmetric. Right?
Yeah, that's
So
the normal. Okay. So when you are taking z-score, you are assuming it is a perfect normal curve and it is definitely symmetric from both sides from the mu. That's the basic assumption. There is no lopsided, there is no skewness. Okay.
okay. So if you have the like other curves like exponential curve and which are
Yeah, there are
not
T
symmetric.
curves. Yeah, there are T curves and then there are your gamma distributions and whatnot. But right now, the fundamental assumption in statistics and machine learning is you are dealing in normal distributions. Okay. And
Okay.
it will look like a Z curve. So all of these p values and z curves and t values are just calculated on this basis and this basis only. If you violate this basis, of course, you cannot calculate. You will again have to do all the integrations on your own. So the idea is standard charts would not be applicable then. Again, you can solve the problem. I'm not saying it is not possible to solve, but then you have to integrate everything very much on your own, or you will have to use computers to do this. Then these standard charts won't work.
Okay.
So can anyone explain me? I just want you to check, okay? It's totally up to you. By looking at this, can you tell me, basically according to me or my information, this is for two tail. Now, can you prove me it is for two tail, yes or no? So this z-score is for two tail. But how would you prove it with that chart that, yeah, you are right, it is actually two tail information. So should we do for middle 50% maths first? Let's start with the, we just got the 80%. So it was 1.28, although of course there is two, but I told you we cannot calculate it. So let's not worry about that. So let's check it out for middle 50%. How would we get middle 50% from this chart? So I just told you a simple trick. Do not think as 50%. So okay, so if you're dealing in 50%, alpha by 2 will be
125.
so look for 0.25. Okay, so if alpha is 0.25, rest of the area is 0.75. Where do you find 0.75 in the upper chart? Or just before 0.75? You will get somewhere here.
Point 0.77, I think. 0.67.
Careful. 0.67. You are good. So z value is z alpha by 2 is where alpha, whatever you were trying to calculate was 50%, 0.67. Let's convert this in my doc, sorry, my PPT as well. Of course, third decimal I don't know, so 0.67 is not wrong. Similarly, you did for 80%, or we already got 1.28. Let's do it for 90% as well. Again, same thing. Z alpha by 2 guys, okay? So this time alpha is 10 and 10 by 0.1 by 2 is Z 0.05, okay? So if you're calculating Z 0.05, so fundamentally you have to look for 95% of the area. Where is 95% of the area? Let's look. So 1.64, it is 1.645 or something, but it's all right. Is it correct or wrong? Yep, 1.645 for 90%. Two-tailed, it is correct. Similarly, you can derive all of this from the same chart that I've been using so far. Or you can find these standard charts all over internet.
Can you show the how to get like minus 25% from the 50% in the middle? Because I think plus 25% I got that one, but I'm not sure about the minus 25 how you get that. Is it from 0 to 25 you get, right? And then subtract that, or?
Sorry, Amartanshu, we are not hearing you.
Hello? I think we lost you.
Yeah, I think we lost.